The length of a rectangle is increased by 20%, and the width of the rectangle is increased by 30%. By what percentage will the area of the rectangle be increased? Okay, so tricky one. A lot of places to get tripped up. So now we know the area of a rectangle is, of course, length times width. Now, there's a couple trap answers. First, you can't take 20 and 30 and average them and get 25 and think that's the answer, because it's not. It doesn't work like that. Similarly, you can't do 20 plus 30 and get 50%. Not going to work the same way. Or 20 times 30 and get 60%. Now, you don't necessarily have to eliminate those choices to get this answer right. You can solve for it directly, but I just want to show you some of the trap choices, what they want you to pick. But obviously, it's not as simple as that. So, two ways to do it. One is to plug in numbers. Second is to do it algebraically. I think plugging in numbers is infinitely better on this question. So, let's pick a length and a width. So, let's do length of 10 and a width of 10. Why not? Right? Technically, it's a rectangle. And let's then increase them by 20 and 30% respectively. So let's make the length, what's 10% plus 20%? Well, 20% of 10 is 2, so we increase 10 by 2, we get 12. The width we're going to increase by 30%, so 30% of 10 is 3, so this becomes 13. The old area, by the way, the old area was 100. The new area is, getting my calculator up. Okay, new area is 12 times 13. Whoops. Okay, there we go. 169. Does that sound right? Let me just make sure I didn't mess this up. 12 times 13. Yeah, that doesn't make any sense. 156, much better. Okay, so old area was 100. New area is 56. So how did this change? Well, it went from 100 to 156, so it went up by 56%. And again, if you're not quite sure about that, you just use your percent change formula, which doesn't come up too much on the SAT, but here is actually an example of where it actually comes up. Percent change formula is the new minus the old over the old value. So in this case, we are doing 156 minus 150 over, minus 100, because that's the old, over 100. Times 100 to get the percent. So we do that and we'll get 56%. So that's one way to do it. Now, if you used any numbers, it would have worked. I picked 10 and 10 just because I knew it would be 100 and it would make the math easy. You can just do it by eye. But literally, you could have used 4 and 6. And then you would just figure out the change to the length and the width and then figure out the new area based off of that and then compare the new area to the old. So that's one way to do it. The other way to do it is to do it algebraically. So define L as the original length and W as the original width. So what would be 20% added to L? One way you can just look at it as, well, if you think about tax and how you compute tax, you can just add the percentage to 1 and then multiply it by the original. So this would be L times 1.2, or 1.2L would be the new length. That's one way to look at it. If that doesn't make any sense to you, think of it this way. The new length is going to be the original length plus 0.2 times L, which again adds up to 1.2L. So that's another way to look at it. Similarly, over here, it's going to be 1.3W because it's going to be L plus 0.3W, which is going to be 1.3W. So now to get the new area, we say the new area is going to be 1.2L times 1.3W. And we do 1.2 times 1.3. Oops, messed that up. 1.2 times 1.3. It's hard to do it with this pen. Equals 1.56. So what does this mean? 1.56 LW. Well, the original area was LW, which means this has gone up by that 0.56 as we saw in the last one, the 56%. So you could see this as, well, this is the same thing as LW plus 0.56 LW, and there is your percentage increase. So again, the answer is 56%. So either way you can do it, whatever makes no sense to you. I think plugging in is the best method, least likely to make a mistake, least likely to get confused. You can use real numbers, so I like plugging in. But again, whatever makes sense for you.